Hello everyone. So today let's solve the problem Mahmoud and a dictionary, right? So this was asked in the code forces around 396 for the division 2, right? So you can just go through the question. I'll just summarize the question so that it will be easier for us to solve the problem, right? So uh, yeah, let's see what the question states here, right? So we are given n words and m relations. See, we have been given n words and m relations actually. Yeah, we have been given n words and this one n words and m relations, either synonyms or the antonyms here. So they can be either synonyms or the antonyms, right? Synonyms in the sense the words which are having the same meaning. Antonyms means this one, opposite meanings, right? So this is fine. You guys will be knowing this one. I just wanted to say this. This is fine. Each new relation may cause indirect connections, right? Each new relation may cause indirect relation. What? Each new relation may cause indirect relations indirect connections basically, right? Each new relation may cause indirect connections, either transitive relations or the contradictions in the sense a word being both same and opposite. This one, indirect connections in the sense transitive relations I'm speaking of, right? So a belongs to b belongs to c, a belongs to c, that one, transitive relations or the contradictions, a word being both same as well as the opposite, right? So this one, for every relation we have to print s. We have to print s. For every relation, we have to print s if it's consistent with the previous ones. If it is consistent with the previous ones. If it is consistent with the previous ones. Or else we have to print no if it is wrong. If it is wrong, right? So if it is wrong, we have to ignore that one, right? After all the relationships, after all the relations, this one, answer q queries whatever will be given in the input basically about the relation between two keywords, right? After all relations, answer q queries about the relation between two given words, right? So one is same here, so just listen to this carefully. One is same, two is opposite, two is opposite. So just pause the video and look into it. If you don't understand, one is same, 2 is opposite, and 3 is nothing but the unknown here. 3 is unknown, right? 3 is unknown basically. 1 is same, 2 is opposite, and 3 is unknown, right? I hope this part is completely clear, right? So this is fine. So we are given n words and m relations, either synonyms or the antonyms, right? So each new relation may cause indirect connections, either transitive relations or contradictions, right? Transitive relations, contradictions in the sense a word being both same and opposite. For every relation, we have to print s if it's consistent with the previous one, or we have to print no if it's wrong. And we have to ignore that one after printing no, right? So this is fine. After all the relations, we have to answer q queries about the relation between two given words, right? We have to answer what we need to answer. After all the relations, we have to answer q queries about the relation between two given words. So here again, let me write here, one is same, we have to display one if it is same, two if it is opposite, and three if it is unknown. Three if it is unknown, right? So this is fine. Yeah, three if it is unknown, right? So this is fine. Let me remove this one entirely. Now, yeah, first let's move on with this one. Input output. See here, we have been given 334. So this one we have been given here, hate, love, like one, this one, 1, 2, and 3 we know, right? One is nothing but the same, two is nothing but the this one, opposite, and one is again, three is nothing but the unknown, right? So this is fine. One is same, right? So this one, love, like, love, hate, love, like, hate, and this one, uh, hate, like. So this one is nothing but the queries that they have given, four queries that they have given from this here. Love, like, this one, love, hate, like, hate, as well as the hate, like. So the output that we need to get here is yes, yes. For this one we have to get yes, for this one we have to get s, for this one we have to get no, followed by this one. These four queries we have to answer, right? By looking at it, we can say love, like are same, right? Same, so we have to get one here. Love, hate, this one, opposite, two we have to get. Again, like, hate, opposite, two we have to get. Hate, like, opposite, two we have to get. So triple two, one followed by the triple two. So this is correct. For these two, we let's see what's the approach. Basically, we have to get S for this. We have to get S for this. We have to get no for this, right? So we have to print S only for the every relation if it's consistent with the previous one. So this one is consistent. This one is consistent. Then this is not consistent, basically, right? So it is wrong, and we have to ignore this in this case. We have to print no and move on with the further things, right? So that's what we have done. So this is fine. I hope the question part is completely clear along with the this one input output. Now let's do one thing. Let's quickly discuss the approach followed by the complexities, and then let's write the code. Let's see what's the approach. First thing I want to tell you here would be we will be going with the DSU approach, also known as disjoint set union with a path compression, or the this one union find, basically. This is fine. Now first, let's consider this one, the same example, the first example that we have considered, right? Uh, let's consider this example itself. Yeah. Now, first, as I've said, we'll be going with a disjoint set union, DSU, right? So with a parity, this one, with a parity tracking. Usually, we'll be making use of whenever we go with this one DSU. So most of the times we'll be going with a parity tracking. Just remember this one, right? So we'll be making use of DSU along with the parity tracking. At first, what we will do, first, suppose let's consider the variable this one, DEP of X, as well as we'll be going with a DEP of Y, right? So this is fine. DEP of X, what it does, the word X has this one, the same meaning as its root. So this is nothing but the word X having the same meaning as its root. And this one, a DEP of, this one, let me give X itself, man. Sorry. Oh, one second, just give me a second here. This is also X itself. So this is this one word X having the same meaning, right? So word X having the same meaning as its root. So this one DP of X. So basically DP of X, this one value 0 when word X is having the same meaning as its root. So DP of X is 1 when word X is having the opposite meaning of its root, right? So I hope this is fine. This is just the variable name. Don't get confused here. This is fine. Yeah, now for each relation, if t equals 1, suppose if t equals 1, then we'll be considering this one as synonym. Then we'll consider synonym. Synonym means with the same meaning, right? Parity between x, this one, x and y, this one, bitwise and y should be 0. Parity between x, bitwise and y should be 0, right? As it is synonym, right? When t equals to 2, we will be going with the antonym. When we t equals to 2, we'll be going with the antonym. And parity between here, this time the parity between x bitwise and y should be 1. X bitwise and y should be 1. See, if they are already connected, we have to check parity consistency. If they are already connected, then we have to check the parity consistency. If conflict, then prints no, right? But then print no, sorry. If they are already connected, check the parity consistency, right? So if they're already connected, check the parity consistency. If there is a conflict, then print no. If there is a conflict, then print no. So if not connected, merge their sets with a proper parity adjustment, right? So if not connected, merge their sets with a proper parity adjustment. Then in that case, we have to print S. Then we have to print S, right? So if not connected, then merge their sets, right? Merge their sets with a proper parity adjustment, Then in that case, we have to print S after merging, right? So this is fine. So this is the idea that we'll be going with. Let's try to implement the same thing for the example one. You'll understand the same one better, right? So that is needed here. That is what is needed here. So words we have here is 3 words we have. See this one. So this one, number of words n they have given here. Words we have here is one is hate, another one is love, and another one is like. Right? One is hate, another one is love, and another one is like. Relations we have here is for these 3 words, hate, love, and like. For this one, we have relations this one. One, love, like, it is 1. Love, hate, it is 2, means opposite. Love and hate are opposite. Love, like, this is same, right? So this is same. 2 is nothing but the love hate. So this is opposite. Hate, like, So this is again same. 8 like this is again same actually. 8 like it is this one is again same, right? So that's what they have given actually. That's what they have given here, right? So this is fine, I believe. So now, yeah, now let's do one thing. So queries we have here, queries they have mentioned here, love like this one. Let me give you queries. First one, love and like. Let me write it in this way. The second query we have here is love and hate. The third one we have here is like and hate. Like and hate. So this one, let me give you I like and hate. The fourth one we have here is hate and like. Hate and like, right? So this is fine. Yeah. For we'll be using the final DSU, disjoint set union, to determine this one basically, right? So we will be making use of the DSU, final DSU, to determine this one. Love like are same, right? Love like are same accordingly with the input. So what we will do, we'll be going with the same. Let me give here S. We'll be going with a one, right? So here love and hate are opposite, so we will be going with a opposite here. So this will be again 2. If same, then we'll be going with a 1. If opposite, then we will be going with a 2. If unknown, we will be going with a 3 basically, accordingly with the question, right? So they have mentioned the criteria within the question itself. Third one, we have like and hate. This one are opposite. Again, we will be going with a 2 actually, right? So this is fine. Final one, we have hate and like, right? So this is also opposite. So this will be given 2, right? So this one, yeah. So now we have 1 followed by triple 2. So this is the output that we need to get here, right? S, S and no we got initially. So this one I love, this one love like. So this one actually are same, right? So we will be going with the S here. Yes, right. So sorry, yeah, yes. So this is fine. So two love hate we have been given here. So these are opposite. So we will be going with the S. Why we will be going with the S here? Instead we have two, right? So this one we have two. Still we are going with this one opposite. Yes, because we will join hate opposite to love. We will be joining the this one hate opposite to love actually, right? So then also we'll be giving S here, right? So don't get confused here. So we are going with the love and hate. So we have to get no. We will be going. We'll join the hate opposites to love, right? So here we have to give S again. So we have hate like. So this one, what happens? This is same, but still this is no. Why this is no? So here also we have considered no itself. See, hate for the hate like we have considered two opposite, right? We have given two here instead of one. So one, this one hate like. So this one is same, still no, because it contradicts hate opposite like. It contradicts hate opposites like, right? So this one will be displaying no. So that is the reason we have got here S, S, no, followed by one, double two and one. I hope this part is clear, man. Easy, right? Easy peasy. So let me delete this one. So this is what's this is somewhat easy to understand. Yeah. Now we are done with this part, right? So we are done with this part. Let's do one thing. Now as we have complete as we are completely familiar with the approach, let's quickly discuss the complexities part. So what will be the time complexity here? The time complexity would lead to, so let me write it over here, because of, so we can just write it like this, because of n plus m plus q into this one, n. So what is this symbol basically? So this is nothing but, what do we call? Inverse Ackermann, right? So this we call it as inverse or inverse Ackermann, right? Yeah. So overall time complexity would lead to because of n plus m plus q into an, right? So this is nothing but the an is nothing but the a, whatever I have written, that is nothing but the inverse Ackermann, right? So this is almost linear man. So overall time complexity would lead to because of n plus m plus q into inverse Ackermann of n, right? So this is fine. What will be the space complexity here? The space complexity would lead to because of n, because we'll be making use of the DSU arrays and we'll be going with a hash map as well. So the time complexity and the space complexity for the code that we'll be writing in the future would be because of this one, n plus m plus q into Ackermann of n and because of n respectively. Now, as we are completely familiar with the approach and the complexities, we are good to write the code. Let's start writing the code. Just come here. So first, we'll be making use of the this one, what do you call, uh, different utilities as well as the input, fast input output. So let me give here input java.input output.star. Let's import the input output package as well as the utility package, right? So I'll just go with this is fine. Next, let's go with a class here. Fine. Yeah, within the main class, what we'll do first, let's go with the initialization part. Let's go with the number of words, relations, as well as the queries. In simple terms, NNM Q actually. In the first line, whatever they have given in the input, NMQ, right? So this is fine. Next, let's go with the DSU parent and the parity array. So I'll just go with here static int, this is fine, FA along with the DP, nothing but the parity array, right? So this is fine. Now, let's go with a word to the index. So I'll just make use of the hash map. We have to convert word to the this one. We have to go with a word as well as the index combination, right? Key value pair I'm speaking of. So let's go with a hash map here. Static, static. So this is fine. Map. Let me go with the string here. Integer. This is fine. Let me keep capital I here. This is fine. Yeah. So I'll just assign the position to. So this one new. Why this is not showing? Oh, we are writing this one for the first time. Okay, just give me a second here. Complete the syntax here. This is fine. Now, we need to store this one. What do we call? Word somewhere, right? So let's go with a variable s here for that. So I'll just go with static here. Mm, of the type string, right? So this is fine. Let me consider variable s. So yeah, now we are done with the initialization part. Let's move on with the DSU. Right. So first, let's go with the this one. Find. With the DSU, usually we make use of the find method and the this one union method. Right. Let's go with the find method with the path compression first. Again, let me tell you one thing. If you don't know the this one DSU algorithm, so that is in the graph playlist. You can just go watch the video and come, right. So it will be easier for us to solve the problem if you understand the algo first, right. So let's go with the find. So usually within the this one, what do we call DSU? Whenever we are considering DSU, we'll be going with the find and the union. Within the find, so we should be able to find the representative or the parent of X. Suppose if we are considering X, right? And usually we'll be going with a path compression within the find method, and union we'll be going with a union by rank. Actually, it can be anything. It may be it can be dependent on the size or anything, right? Usually we'll be going with a union by rank, right? So we'll be attaching the smaller ones to the larger ones usually within the this one, what do we call union. First, let's go with a find method here. DSU find with a path compression. So let me go with, sorry, static here. Mm, Fine. Uh, Let me go with the parameter x. So first, let's go with the base case for the root actually. If mm, f of a here, so this is simple. Not f of a, sorry, we have considered fa, right? Fa of x. Yeah, fa of x, if it is equivalent to the x, then what we will do, we'll return x, right? So the next step here would be, let's go with f here. Uh, Let me go with find of this one. What do we call? Int f equals find of fa of x. This is fine. Yeah, we are just finding the parent's root. Next, let's do one thing. Let's accumulate the parity to the root, right? So we'll go with dp of x equals dp of fa of x, right? So this is fine. Yeah. Next, let's go with the path compression. So I'll just go with return fa of x equals f. Yeah. So let me come out of this one entirely. Now let's go with the main method one. So this is it for the find. So let's move on with the main method actually. So I'll just give main here. Let me remove this. Yeah. So let me give here. I don't have to consider here exception and all. So this is fine, man. This works. Actually, let's go with a scanner. Scanner is enough for this, right? So sc equals new. Let me go with the scanner of system dot in. This is fine. Yep. Now let's do one thing. So we are going with the total words, total relations, as well as the total queries. This one. this is nothing but the total words. We have three words here: hate, love, and like. So this is nothing but the total relations. This is nothing but the M here. Three relations we have here. See here, this one. And this is nothing but the total queries. Four queries we have here. This one. Sorry, this one. Yeah. Now the same thing. We have to read that, right? So I'll just go with n equals. We are making use of the scanner. Scanner dot. I'll just go with the next int. No need of buffered reader and the this one print writer for this. So this is fine. I'll just make this one capital I, right? So let me copy this entirely. Let me paste this one. This is fine. So now M. So this I'll just go with a Q, right? So this is fine. Now, yeah. Now let's do one thing. Let me go with S equals new. I'll just go with a string actually. Let me go with a new string of size n plus 1. Yeah. Now I'll just go with the FA equals new int of size again n plus 1. So this is fine as well. Now let me go with the DEP. So this one will be new int of size. I'll just go with n plus 1. Right. So this is fine. So after the initialization part, we have to initialize the DSU as well, right? So let's do that one first. Let me go with the for loop. Let's move on with the iteration. So this one will be equals 1 I less than or equal to n. Yeah, this is fine, man. Sorry, what did I do here? Yep. Within this for loop, what shall I do? First, we have to read the word and we have to map the word to the index. These two things let's do first. Let's read the word s of I equals scanner variable sc dot next int here. This is fine. Next thing is let's map the word to the index. Let's go with the position dot this one. What do we call? Put actually. This is fine. S of I comma I. Yeah. Now let's do one thing. Let's assign the parent to itself, meaning a parent here fa of I, right? So let's assign this one to the itself, nothing but I, right? So this is fine. Let me come out of this one entirely. After so many days, we are solving somewhat this one medium problem. Yeah. Now let's do one thing. Let's process the relations. We are done with the DSO part. Now we have to process the relations, right? So this one, synonym, antonym. So converting 0 to 1 actually, convert to 0 and convert to 1. Sorry, not converting 0 to 1. Convert to 0 as well as convert to 1 or convert to 2, right? So that one, that we have to do actually. First, let's do one thing. Let's process the relations. Let's go with a for loop. So this one has to be int I equals 0, I less than let me increment I. So within the for loop, what we'll be doing, I'll just go with opt equals this one sc dot next int, right? So this is fine. So the next step would be just go with a string str1 equals scanner dot next int. This is fine. Yep. The next part would be string this one. This one will be str2 next. Yeah, sc dot next actually. We don't need in. We just have to go with the next, I believe. This one also let me delete here. This one also let me delete here. So or for this one we need int, right? For the sorry, yeah, this one let's include the. For this one we don't need int here. We are going with a string actually. String one, string two. Right? So this is fine. Now after this, we have to convert to 0 if it is same, and we have to convert it to 1 if it is opposite. So I'll just go with opt. Let's decrement this one. So the next thing here, let's go with the initialization of certain things. I'll just consider here x equals position dot get here of, let me pass string 1. Same thing, similar thing with a y. Let me go with position dot get here. So this one has to be, let me pass string 2. Yeah. Now let's consider px and py. Px, let me assign this one to find. So here find of what? Find of x. So that is the reason we have written the find helper method, right? So we went with the path compression there. So py equals find of y. Yeah. Now, let's move on with the further things. So if it is already connected, then we have to check the consistency. So I can just write it in this way. If px value, if it is equivalent to the py, meaning if it is already connected, then we have to check for the consistency. First, let's do one thing. Within the if condition, we have to compute the relation parity between x and y. So I can just write it in this way. So this one is quite tricky. So I'll just go with REL equals here. Let me write dep of x minus, so this one has to be dep of y. This is fine. Dep of y, this is fine. Modulo 2 plus 2 here, right? Plus 2 here. So this one is fine. The next one would be, let's go with a system out println. I'll just go with a println here. Mm, yeah, this is fine. If REL, this one, the value is equivalent to the opt that we have considered, then accordingly with the criteria they have given in the question, we have to print S. Else we have to print no, right? So I'll just give this one within the strings. So this is fine, man. Next one, else if px is not equivalent to the py, then what we need to do? Then what we need to do here? Again, let me go with println. Yeah, this one system out println. Then we have to print S. Yeah, followed by this one. We have to go with a parity adjustment for the root px. Also, we have to merge the sets. Let's do these two things very quickly. So this one will be dp of px equals dp of y minus dp of x plus, let me go with a, this is simple. Let's merge the sets. Merge the sets. So we have to merge the sets accordingly with the approach that we discussed, if you remember, right? So px equals py. Yeah. Now let me come out of this one entirely. Now let's do one thing. We have to process the queries. So this is the last step, right? Processing the queries is the last step. So now let's move on with the for loop. So this one will be int I equals 0. I less than, we are processing the queries, nothing but the variable q here. We have considered I plus plus. So within this for loop, let me go with the string. First string actually. String str1 is not showing here. Why? I don't know, man. String str1. Let me go with scanner sc dot next. So this is fine. String. So let me consider here string str2 equals sc dot this one. Next, and let me go with the next one here. Right now, let's do one thing. Let me assign x2 dot get here. This is fine. Let me go with str1. Yeah. Now let me go with y equals dot get of this one str2. This is fine as well. Now let's go with the px as well as the py. Px, let me assign this one to the find of x as well as the py. Let me go with py equals find of y. This is fine. Yeah. Now we're left with only thing, only certain things actually. If what if they are different sets, right? So if I can just write it in this way. If px not equal to the value py, right? Then what we need to do? It's unknown, right? So we have to go with the three actually. We have to go with one same, two opposite, three unknown, right? So if if it belongs to the different sets, then we have to print unknown, right? So I'll just go with again system out println here. This one, let me go with three within the string. Else, we have to print same or the opposite, right? So I'll just go with rel again. This is equivalent to dep of x, yeah, minus dep of y. This is also fine. Modulo 2 plus 2. This is also fine. Modulo 2. I should have copy pasted. This is fine. Next, let's go with the system out println. The same thing, man. So let me copy paste this. So this one println if Arial if it is equivalent to instead of opt, let me change this one to 0, right? If it is 0, then we'll be printing basically instead of yes, we'll be printing 1, instead of no, we'll be printing 2, right? So we are going with the same or the opposite. If Arial if it is equivalent to 0, then they are same. We'll be going with a 1. If it is not the value, if it is not equivalent to the 0, then it is opposite. Then we will print 2, right? So this is fine, I believe. So this is it for the code, right? So I hope this is correct. Let's see. Before checking the code with the different inputs, let me copy paste the signature starter template. Just give me a second here. Yeah. So let me paste this one here. Yep. Uh, hmm. Let me do one thing. Let me come here. Let me copy this one. We have to get the output double S no followed by 1 2 2. Let's check the same here. Error. Yeah. Identifier expected. Which one? Line number 23. 1 second. 1 second. 1 second. 1 second. So we have directly given an MQ or what? Yeah. So I have not given. So these are of the type int, right? So this we are considering this one NMQ. Oh, all the three are of the type int, right? So this is fine. Let me run this one again now. So this 5, so this has to be actually modulo, right? So this one line number 63. Yeah, let me change this one to the modulo. So shift doesn't work sometimes. So let me run this one. Now we have one more error. Incompatible types. Int cannot be converted to the string. sc dot next int line number 46 actually. 46, 46. So this one, I think we just have to go with the next then. If int cannot be converted to the string. Yeah, now I think both are even now. Both are strings actually. Yeah. Yeah. Now we are getting the correct output. Double S no followed by 1 2 2. Those were some of the typos actually. Let me copy this one. The output that we need to get here is 4 times S followed by no followed by S and finally double 3 double 1 2. Let's check the same. Run now. So sorry, paste this one at all. So yeah, 4 times S followed by no S, this one followed by this one, double 3 double 1 2. So this works absolutely correct for the examples that they have given in the question. Let me copy the entire code. Let me come to the submission part, select D. Let me paste the code and hit the submit button. I hope this works for all the test cases. Let's see. Let's wait for some time. It's showing it's still in queue. Let's wait for some time. Test one. This is so slow. I don't know why. Test three. Yeah, let's wait for some time. So here in the toast it is showing accepted, right? In the toast it is showing accepted. So yeah, the verdict that we got here accepted means we whatever the this one code that we have written works absolutely correct for all the test cases. We have purely made use of the DSU here, right? So with the parity testing, right? So to solve this particular problem, this works absolutely correct, right? So let's do one thing. Yeah, I hope the solution part is completely clear along with the approach and the complexities. For now, this is it. Thanks for watching, guys.